Hi, in this video we will look how to take root motion animations and create a playable character and NPC bot from them. And for this video we will use those wolves from Poly Art Wolf pack, which is free now on the marketplace, but the techniques showed here are not really related to animals or to wolves. It's work with people too, even better. So at the end we will have something like that. We will have a wolf that can be controlled by the player and another one that will follow him. And also important to note, this tutorial is pretty beginner friendly, so some things I will explain in some simple things I will explain in detail, so feel free, if you already know that, skip those parts. Well, let's get started. To start, we create a new project from third-person template, and we install the Poly Art Wolf pack in this project. This pack will create a folder where there are different stuff coming with. What is interesting for us is the animation folder. Here you have various animations. We are interested by root motion animations, and we also need some from there. So let's first just look what is root motion and how it is used in Unreal. So there is one example. So as you know, probably this is a skeletal mesh, and this is the skeleton of the mesh. Each bone is this skeleton controls some part of the animal of the mesh, and the top of the hierarchy is called the root bone. Here it's literally called root, and this bone controls the whole mesh. Now we have an animation here. Basically, inside this animation, each bone has a track, and it records the position and the rotation of this bone for each frame. We have 24 frames. So if we take one of those, you can see those numbers change. And the root bone is not different. It also can have a track, and this whole mesh will be animated. But Unreal treats root bone differently that other bones. There is a special checkbox here, root motion, enable root motion. For this animation, it's already checked because it comes from this pack that already pre-configured correctly, and it means that when it's checked, it means that the animation of the root motion will be proceeded in different way than other bones. So let's see. If we uncheck it, we will have our wolf that kind of starts to walk and then snaps back to 0. Then what you see here is the animation of the root bone, and of course this animation is looping, so at the end it will just restart from the beginning. What a root motion exactly means is to instead of just playing the root bone as any other bone, extract this animation, this data, and apply it directly to the character. And when the character comes to the end of this loop, just not snap it back, but continue from where it was. And for that, there is another checkbox to check here in the preview. It's located in character animation process root motion. And now, as you can see, our wolf is just walking in circles. And that basically what root motion is. Okay. Now we can see that we have those animations for walking in circles, turning, and walking straight. So you have walk forward, walk left, walk right, trot forward, trot left, trot right, and run forward, run left, run right. We'll take those animations and create a blend space. And I created a separate folder for our tutorial stuff. So we will go here and create a blend space for the wolf skeleton. I will call it I don't know, move blend space. Let's open it. So the blend space, it's like that. It's kind of a grid, and you can put different animations in here. And there is two axes that you can control with two variables, and then it will blend the nearest animations. Let's see how it works. Let's take, for example, let's start with the walk forward. Put it here in the center, and walk left in the left, and walk right in the right. Now if we play it, we can already hear by keeping shift key holder and moving the mouse, make our wolf walking in different directions. You see the blend space will blend between walk left, walk forward, and walk right animations. We can already say our x-axis is called turn, and it goes from some angle to some other angle. I put 60 because I just tried different values. Kinda looks okay, and but you can try yourself. Probably there's other values that are better. For this tutorial we will use angle in degrees, and then the y-axis is the speed. So we will take our now trot forward, trot left, and trot right, and run forward, run left, and run right. And as you can see, now we can go faster, and we can run too. So this axis will be called speed, and it will go from 0 to 1. And come back here, and so you can think about it as if you have a controller, how much your joystick is tilted. So for example, for 0.5 it will walk, for 0.75 it will trot, so run slowly, and for 1 it will sprint. And that's it. We created our blend space. Just to another thing we can do here is that we can move it back. Okay. Oh, now you can see this wolf reacts very quickly to the mouse input, and that can look a little bit mechanical. So if we want to smooth a little bit this, we have here a parameter called sample interpolation, and if we by 0 means that it's not applied. If we put some number, it will smooth it. So like if we put 1, it will be kinda very pretty slow. You see, it reacts. And let's put like 3. That seems okay. And that's it for the blend space. Now let's create another animation asset, call it animation blueprint for this animal. And we will take our wolf skeleton and create one, and we will call it wolf anim blueprint. Anim blueprint is where your animation logic will be located. Probably first thing we need to do here, you see this root motion, and as we already seen here, we had to enable it in preview in the character animation. And that was only for this preview screen. To enable it really for the character, you need to enable it here, and you need to say root motion from everything, so it will be processed. And here you have 2 parts in this anim blueprint thing. You have anim graph that we are looking for, and that's the thing that will compose our animation that the wolf will play. And then we have event graph that is kind of normal blueprint that will calculate different values of variables and stuff like that. We will create the anim graph, and for that we will create a state machine. And inside this one we will put our animation state machine. So it's very easy for this case. We'll just create 2 states. One call it idle and one call it mover. And in the idle state we will put an animation, which will be just our idle animation, something like probably that. And then let's check it out. So our wolf now just playing this, and that's okay. And now in our move we will put our blend space that we created. Move this, and you see it comes with 2 entries where you need to put some variables. So let's create already those variables. One we will call it turn in degrees, and another we'll call it speed. Okay, but we still need to calculate them somewhere else. And finally, we will need to say when this transition is activated, so when the valve goes from idle state to moving. So here we create another variable. We will call it is moving. Is moving. And it also should stop. And this is simply is moving, get is moving, not. And that's it. We have this part done. Now, of course, we need to put some numbers into those variables, because otherwise nothing will work. And for that, let's move ahead and create a character. The character is the thing you put in the level, like this white guy. We will create a character. Print class character, and we'll call it wolf character, wolf char. And that's a normal character. So see, here you have the root of the character, the main entity, the main component is the collision. And there's also the mesh, and this arrow just to see where it looks. So in the mesh we have to put our wolf, right? There's two wolves. I will put those magic wolves because it's simpler to see. And right now it appears in the air, and the capsule also is too big. Let's turn the wolf first. Now it looks like this blue arrow, and also let's move it a little bit like so in the center. And our capsule, probably it's too big still, and we will put it at, I don't know, 50. And you see here that this what we are doing is not really especially for animals. Actually the part this is, I would prefer to have some other collision for the wolf, because the head is outside of the collision capsule. But yeah, the character movement, character component of a character actor only supports this kind of collision now. At least I don't know how to make it better, so but it's okay. And yeah, that's it. Now we can already take our character, put it in the level, and yeah, say that it will be our player. We need to possess it. That's it. Now if it play, nothing happens because we don't do anything with the input we receive yet. Let's start doing this. Yeah, first of all, let's also hook our blueprint we're just done. Oh, now already better. And we need a camera too. So we'll add a camera. No, it's not the camera, it's the camera stick that I always forgot the name. What's this thing? Spring arm. So we have the spring arm, and on this spring arm we will put a camera, and we'll attach it too. And maybe we'll move it a little bit higher. Now if we play, we can see our wolf, but still no way to control it. Let's put some control code in the event graph. We'll simply take the third person character that we just deleted from here and copy what it has in here. That's why we started with third person character, because all those input axes and all this blueprint are already here. For the input axis, just to show you, in project settings, input third person character comes with move forward, move right, turn rate, look up rate, look up. We use all those. So move forward is W or left joystick, and turn it mouse X, and turn rate is right joystick. Classic stuff. So we will just took some of those. I will take the turning of the camera and turning with the mouse and the walking movement. Ctrl C, Ctrl V, and we have those here. Let's just briefly look at those. This is the turn for the gamepad. You see, if you tilt your joystick like right, it will take the value, how much it is tilted, from 0 to 1, multiply by a number which is actually should be created, and multiply by the time and second, and feed that to add controller yaw input. So this thing will rotate the camera. Controller rotation is the rotation of the camera. That's important. And the same for the looking up. And those variables, they by default they are initialized to 45 degrees by second. So which is important to know here, and we somehow deleted this, which is important to note here, that controller rotation is the rotation of the camera. Now for the mouse, it's just directly taking the value of how much the mouse moved and during the frame, and feed it to the controller rotation. And this one we will look later. So if I play now, yeah, I can rotate the camera, and as you can see, I also can rotate the wolf, which is not what we want. So we have to check some checkboxes. Let's go into here, and first thing we have to uncheck use controller rotation yaw. So with this checkbox checked, it is checked by default. The whole mesh, the whole actor will rotate according to controller rotation, so to the rotation to the of the camera. That is not something we want. And now let's just look if we have something else. No, that's okay. Now if we play, we cannot move. That's because this guy should use the control rotation, this, of the pawn of the character. Now I can look around the wolf, but I cannot. I can move. That's great, but you see, that's the default behavior of the character. It's funny. It happens because we have this character movement component here. This character movement will use the data we feed it here, and will rotate the actor accordingly. So now what we are trying to do now is to, instead of that, is to move this character during the using the animations, so mainly using this blend space, and that will override whatever this thing is doing. But for that we of course should play something here, because until now our wolf still always in the idle state, because this variable is moving, for example, and those variables are still at 0. We still didn't assign it anything to them. So now let's look at the movement input. Movement input, it's the same that in the third-person character, and it will do a very simple thing. It will take the control rotation of the character. As you remember, the control rotation is the rotation of the camera. So for example, it's where I look now, so you see the direction. For example, here the direction forward is this wall, and the direction right is the stair on the right of me, and here forward is the stair, and the right in this wall on the right. So it will take the control rotation, take the yaw, the angle of rotation, this axis around z axis, and we'll make the rotator from this yaw, and this just will put x and I to 0. So if we like I don't know, we are looking like that, it will not interfere in any way. And then it will take the forward vector, the direction that are we looking at, and multiply it by whatever comes from the input in this direction. For example, here we have move forward, so if you press W, this will be 1, and it will multiply this direction in wall space by 1. Otherwise, if you don't push the W key, or it will be 0. So add movement inputs here will receive just a 0 value, and if you push S to go back, it will receive -1. So it will go. This vector will be in the opposite side. It will point backward. And the same thing for the right vectors. It's multiplied by the value of the right input, move right. And then it will add it like so separately, and simply the movement, character movement, or the character itself, I don't remember which one it is, it will simply took those two and sum them. So if you want more control, you can also take those values and make a sum here, and then, I don't know, apply some other modifiers on them, like you can normalize them, you can multiply them for some with some number. If you, for example, want to walk slowly when you press Control, and sprint when you press Shift, you do those things, those calculations here, and just at the end you use one of those nodes. In my other project here that I've already did before, you can see that there is this code that basically will, on every tick, use the same kind of calculation: control rotation, break, take yaw, take forward vector, multiply by move forward, and then add, and then on that it will multiply them by something. For example, here it will multiply by a number, so you can sprint when pressing Shift on your keyboard. But for this one we will not use that, to keep it simple. Just, you know, those two, they will simply be added together by the character, and it will be actually take this, multiply by this, and then add them both. Nothing very complicated. So that's it. We have our wolf that is kind of moving, but well, still not what we want. Now the most interesting part is coming. We have to take those numbers, and we will have to calculate those two values and play this animation. And this is done here in the Anim Blueprint event graph. So let's make our wolf walk and run. As you remember, we have calculated the movement input vector by combining the control rotation, the rotation of the camera, and the input. That one vector, and another vector is the actor rotation. So it's the, if you want, the rotation of the wolf itself, of the character, this red arrow. And for example, now the wolf is looking right, no, and I'm looking in this direction. So if now I press W to go forward, the wolf should turn like so, no? If I want to go forward from here, forward like that, I expect my wolf to turn. And if I'm looking like so and I go forward, I don't expect my wolf to turn. I just want to go forward. And if, for example, I press A key, I want it to go left, so to turn it to go left. And we need to calculate this. Look how, as you can already see, it will be the difference, the turn. It will be the difference between the direction of the actor and the direction where we want to go. So let's just do it. Well, actually I already wrote it because to make things faster. Let's look how it's done. So if in Wolf anim BP, we will go to the event graph here, and there is an animation. There is an event that is called every tick of the animation, every blueprint update animation. It's there that we will put our code. And it works like so. First we take the owner of the anim blueprint. In this case it will be simply this blueprint, the character, and we'll cast it to character because by default this thing returns a pound and we need a character. From this character we will take the movement component, which is simply this thing defining the movement of the wolf, and from here we will take this data, get last input vector, and the last input vector is nothing else that this stuff. It's actually that plus that. It's the sum of the last movement inputs it received. So it's where we want to go. And from here we will calculate the rest. So in some sense we will take from the character movement what we put here in character movement and then say, thank you, now we handle things from here. First we calculate the speed, which is very simple. It's just the length of the input vector. As you can remember, the blend space, we use the speed axis to be between 0 and 1, and it starts to work at 0.5. So if you tilt your joystick at half, it will start to work, and if you tilt it full, it will sprint. So just that. And the isMoving variable is just the if you want if the speed is bigger than 0, then we are moving, otherwise we are not. And finally the turn, it's a little bit more complicated, but as I said before, it's the difference between the movement, the actor rotation, and where we want to go. So here we take this input vector, we normalize it. Then we take the rotation from x vector, so it's simply in world space how much I should rotate to match this direction. So it's direction we recreate the rotator from this vector, and simply we take the actor rotation of this character and make the difference of 2. And this is our turn. The yaw, the z value of this is our turn. Here I also multiply it by this is actually the multiply node. I don't know what it displayed like so, but it's a multiply, so I can break it here to see it better. and we need to just to use the z-axis, and I multiply it by the vector length, so if there is no movement it will have no turn, and this just makes things a little bit smoother when you start and when you stop movement. And yeah, that's it. Just you can see it here. If you need to copy that, you see update, tac tac tac, speed is the length of the input, is moving is the when the speed is not equal to 0. The turn is the difference between where we want to go and where we are looking now. And that's it. Now if I compile this, we have as you probably remember, we have this wonderful, there it is, I don't know where it is, but we set the we set the here we said that we will use root motion. So now instead of calculating the movement itself, the character movement component will just take whatever we feed from here, and it means from here, and we'll use it to move the character. So now when I play, we can walk, and we can run, and we can turn, and it works. You see, of course you cannot have this kind of smooth transition with if you use keyboard and mouse, because keyboard is just two values. Here I use a controller, and if you use a keyboard, you need also to create input, assign input keys for sprinter, for slow walking, and then, as I explained it before, use them in the player character to calculate the correct speed between 0, 5 and 1. Okay. Now last part, let's make a friend. Let's make another wolf that will follow us, and for that we will say that this one is not possessed, and we need to say who to follow to start. So here in our wolf character we'll create a variable, and we will call it, I don't know, leader, and it will be another actor. Actor. Okay. So now I can say this one, your leader is this one, follow him. But of course we still need to create the AI for this. Let's do it. Okay, so let's get started by creating an AI controller. Here, blueprint class, and we will not take player controller here, but we will use a special one. It's called the tour card AI controller as parent, and this we'll call wolf AI. We use that because it's supposed to be a little bit better than the default AI controller for following paths and avoiding obstacles. The first thing we need to do with this one is to go to the wolf character and to say when you are an NPC, then use this AI controller. Check, this is done. Now we need to define the behavior, following behavior of the wolf. So for that we will create a thing that is called behavior tree, and we will call it wolf pt. This behavior tree, it needs another object that we don't have here yet. It's called blackboard, and the blackboard is something that contains variables for the behavior tree. So behavior tree is separated between the tree itself and the variables it uses. And now wait, something is strange. Let's create it like that. Blackboard. That's just that. Now we need just one here variable. That is our leader. That's an object. And we'll call it leader. And then here I will say that actually it's an actor. Yeah. Save. We don't need it anymore. And here we just have to say that we use it. And now our blackboard defines the behavior. So it's very simple. It will follow the leader. It will do two things. Move to leader. Already all things are automatically set up for us. Or if you can't, wait. And that's basically it. And we will say that the acceptable radius, it's a little bit bigger, because we don't want those two to really overlap each other. And that's it. And now we have to run it inside the AI controller. So here on begin play, so that's the code that will connect the Wolf AI controller and the behavior tree. In the begin player of the AI controller, we will take the pawn that we are controlling, the wolf, cast it to wolf, and then take the leader variable we just created, check if this variable is valid, and in case it's valid, we will call run behavior tree node with our behavior tree wolf bt just created, and then we will take the blackboard like so, and we will put the leader value of the leader variable inside this blackboard, and by using this kind of construction, set value of object with here name leader. And then that's basically it. Then when game start, begin play, this code will be executed and will start to running the behavior tree, and also start to set the value of the leader for the behavior tree to run. Before we start to testing our AI, we need to place a nav mesh bounce volume in the level. So we take this one here and we scale it, and if you press P key, you can see where the volume goes, and this volume is needed for the pathfinding system to know where the character can go. This is done. Now let's look if it works. Yeah, it kind of works, but something's still wrong, right? And this is something that's last thing we have to do. Involve character movement, search for acceleration, and there is this thing, use acceleration for path. So the deep meaning of this checkbox is to use the character movement component. In other words, use the movement input for AI controlled character. If you don't check it, it will kind of try to move the character itself, and as you can see, the character moves, but there is no animation or playing, because our movement input, it stays always at 0, and the anim BP doesn't receive anything here, so it stays in idle. There is no move root motion animation played, so you see it will move, but in the idle state. And now when we finally check this checkbox and play it, as you can see, that's the big moment. It will run a little bit nervously. So if you want to avoid this nervousness, you can go into behavior tree, add a cooldown here, which is here, like so, for example, for, I don't know, maybe 5 seconds. It's too much. I'll do seconds. And now it will like wait a little bit before continuing to follow us. And of course you can then add much more things, and in this behavior tree, actually my original behavior tree is a little bit more complicated. You have here the same selector, move to, and wait, but you have also this node is at location, so it will not move it. Try to move it. If it's already how to say at proximity, and it's set as inverse condition. So if it's at 5 meters or less from the leader, it will not move. There the same cooldown that we input, and of course you can put much more behaviors. So that's it. That concludes our tutorial. I hope you like it, and if you have any questions, remarks, or something to say, please use the comments. I like very much to answer the people in comments. Thank you for watching, and see you next time.